Hello viewers, welcome back to MultiMagix channel. This video is about a retrospect of the MultiMagix product. So as a part of this retrospect, we just want to touch on where we started our product and where, in the sense like where we are in the previous retro and what's our progress so far in the last couple of months as a MultiMagix product. And we do want to explain this product development mostly through the challenges we faced. So these challenges are quite common in any software development or any product development. Hope these challenges and some kind of decision making what we made to overcome these challenges might definitely help you as a part of your product development. So that is one aspect we do want to share with the viewers, and of course we also want to share our progress. So let's start this video now. So the next slide is about so where we are actually. The previous retro, as we mentioned, the MultiMagix product is a media application, and we are in specifically so we are specifically into multiple platforms like Linux, Mac OS, Windows, iOS, Android, and Raspberry Pi. So when it comes to the first feature we worked on is on video to audio. So I will not go much details into it, because as you know, if you watch the previous video also, you will come to know what is about that particular video, what that particular feature does. So to cut short, yes, we extract audio from a video file. So if we have a video which has MP4, an audio and a video, these two packed together as a container, and we can just extract audio stream and write to a file. So for example, if we have an MP4 file, we can extract the audio and write that into an MP3, and same like, so we provide here the 32 combinations like MP4 to MP3 and MP4 to AAC and MP4 to AC3 and MP4 to OAG, and again the mapping goes on 3GB to MP3, 3GB to AAC, and so on. So this is the first main feature of our product, and this feature is up for all the platforms, and same comes to video to video. So when I say video to video, of course you have a video stream and audio stream in a container, and of course the output will be also a container, same container, and it has video stream and audio stream. But what difference we'll be doing here is, like, yes, in the audio stream has its own codec and video stream has its own codec. So we will be transcoding the video from one, transcoding means like transforming from one codec to the other codec. So it can be both audio and video, or it can be at least for either of them. So here we are transcoding from x262 to x265. So yes, if you want to improve quality, you can go for this transcoding, and during the extracting video, this is the like similar to the audio. So let's say for some reason if you want just the video file from your original file which has both audio and video streams, you can just simply use this particular feature, and here you can extract the video. And trim is nothing but, you want to cut down few unwanted frames, or if you want to do like unwanted additional data, all those things you can trim it. And the trim is based on the timing, so you need to mention the start time and end time, and that particular part you will be getting, and remaining details will be trimmed. So resize is like you're changing the resize, means here it's not about the size, it's about the resolution. Let's say if you are having a certain resolution like 640 to 320, if you want to upscale or if you want to downscale, we can refactor. We can, using software context in the FFmpeg, you can refactor it using resize. That's about the resize. And the next is about audio to audio. So this is similar to the first feature. Instead of having multiple, instead of a video file where it has both, instead of a container which has both video and audio streams, we just pick a container which has only audio stream, and if you can convert this to any format. So this is simply a kind of subset feature of the first feature, but still it's definitely useful in the world of conversions. Okay, so we started our journey majorly on the conversions, because that's the basic feature if you are working on editing tool, or if you're working on any legacy feature. So that's the basic thing to start. And yes, we also started, and we had a lot of learnings and challenges in this phase, and yes, those are all captured in the earlier videos. You can go through it, but just for the beginning of this video, I just want to quickly capture that here. So let's move on to the next video. I mean the next slide, my bad. So the next video is about this slide is about a new feature we worked on. Yes, this will be a very interesting feature. It is called 1 second. Yeah, this feature is called a playback control. You can see if you're streaming any video, if you are playing any video, you want to control the speed of that. So let's say if the information is, if you want to completely fast, increase the speed of that video, if you want to decrease the speed of that video, everything you can manipulate the strip playback control. So we started with this particular feature, and we want to slow down. We started with slowing down. So this is the video, it is in playing fast motion, the Iron Man trailer, and the same video is in a slow motion video. So I picked two different clips from the trailer. Yes, currently we are supporting, you can speed or slow only video by any factor, like 0.25 means you want to slow down by 1/4, you want to slow down by 3/4, and if you want to increase double, twice, 1.5. So any factor we are supporting currently. And we also developed a speed video and audio together by a factor 2. Okay, yeah, it means like if video is playing fast, audio is also playing fast by the rate of 2. And there are other options in this playback control. The interesting options, yes, you can audio see at the end, audio stream and are two different streams. You can apply one functionality to the audio stream, and you don't need to apply, or you can apply other functionality to the video stream. But main thing is that a real-time use case should be there for that, and also there will be no sync issues. So that is the main thing you need to focus when you're dealing one functionality on audio and one functionality on the video. So just to try different things, we also telling that okay, with the current MultiMagix product, you can just speed video and then leave the audio as it is, and the vice versa. You can just keep the video as it is, and then you can just increase the audio, just in case if that is helpful for you. We just want to provide those additional options. And yes, but of course the rationale is we want to increase the or decrease the speed of a video along with audio by any factor. Okay, so whatever we are achieving only for audio, we want to achieve the same thing for video and audio together. Apart from this rate, double the speed. So if you want to increase 4 times or 1.5 times, we are trying to generalize the algorithm behind this playback. Okay, so what key challenges we got? See, during any product development, basically see, everything will be not fallen in place at a time. So sometimes you need to start at some point, and then it keeps maturing as the time matures. The product keeps evolving, and the more ideas come into the picture, and it's like the better, it keeps on betterment every time. So it's some kind of we need to start somewhere. So we started with this doubling the video, just the video with the set PTS filter. Okay, so this is a simple, looks like a simple filter, but it's a video filter. You have to configure it properly. You need to initialize properly. You need to set all the configurations, the buffer context, buffer sync context, buffer source context, all the different things you need to do it properly. So once that is done, then you need to use it during processing frames. So that is one particular challenge we got, where we need to reuse it. What now, the actual major challenge comes if you're trying to use this tempo filter for audio stream. So video stream, you are applying one filter, and audio stream, you are applying one more filter. But individually both are working good, but when it comes syncing issues, there is a lot of sync issues came, and even the audio is double. There are a lot of background noises there, so it's not audible, and it's not giving that smoothing experience. So what we tried is okay, so here's the thing. So when you're trying to do anything which is built by any third-party library or thing, yes, you are free to do it, but here in this case, yes, it's not working. We tried, okay, instead of relying on a tempo filter, why can't we design our own tempo filter? As I said, it keeps evolving. To start with the idea, we just designed our own audio filter, where there will be, as discussed in the earlier videos, we'll be just picking up the alternate samples, and we'll be ignoring other samples, and we should take care about PTS, DTS, and the number of channels inside each audio frame. So all those details you need to consider, and you need to design your filter properly. So this way we are able to achieve the playback. Now you can increase the speed by 2 for both video and audio, but if you're only dealing with video, you can play it to any other factor. And of course we are providing additional options as mentioned here. So the next feature we worked on is okay. So I thought, okay, so now let's see. So now let's work on this reverse feature. So it's found me very interesting. You can see, like sometimes in movies or like that, okay, this reverse effect creates a lot of nice illusion for us. So I thought, okay, let's put it our efforts on the reverse. So that's where this particular feature started. Yeah, idea is just simple, but when you start doing it, there are a lot of challenges. But before going into the challenges, I would like to see what different options are available here. Okay, so one is reverse video. Okay, so in general, I don't want any audio, just want to reverse the video. Yes, MultiMagix product, you can do that. And then if you want to just both reverse video and audio, yes, that too we provide. And there are additional options, like if you want to reverse video and keep audio as it is, yes, you can do it. And if you want to keep video as it is and just reverse the audio, so it's just like you're playing with the streams. You have video stream and audio stream. So you can disable one. I mean, currently we are not focused on disabling video stream and only just enabling audio, because it's main dealing with the media files, right? So we are focused just play around with the audio and keep the video constant. So first is keep video and no audio, and then video reverse, and then just audio as it is, and then like that we are playing with the combinations. Total we have 4 combinations now. So in the reverse, the major challenge again, so video is bit straightforward. Video, if you want to reverse, currently we are following a buffering way where you need to store both video frames and audio frames, so via deep copy. What is meant by this deep copy? So deep copy is in the sense, like, see, we are creating a buffer, and we are storing in that buffer, we are storing the pointers of the frames. Okay, so now if you want to copy that all the AV frames into the buffer, you don't want to copy the pointers, you want to copy the actual data. So we need to create audio buffer and video buffers in such a way, instead of copying the pointers and storing it to the buffer, you need to copy the actual data. So we tried multiple ways, but yeah. So one strong recommendation is, whenever you are stuck during any new things, it's also better to go to the official documentation. So in this case, I went to the FFmpeg official documentation and gone through how to do this, how to copy a AV frame properly without losing its essence, like the data and parameter as it is. And on top of that, if you want to override any of the properties, how do we do all these things with the help of the APIs provided by FFmpeg. So in this case, we took a decision, okay, let's go to the documentation. And also, while reading from the buffer, so let's say it's again the same. So you are pointing a pointer, and then if you try to read it, just a pointer address you will be getting. So you need to be very thorough in the pointers concept. In general, if there is a large amount of data, we not actually store the data. The buffer is there once, but we in one context we point it in one way, in other context we point it other way. So you need to ensure that referencing, unreferencing, pointing, copying, whatever based on the needs, you need to have a thorough concept around the pointer. So that is, I would say, not challenging, but it's good to refresh all those things. Actually, that really helped us here, and of course our mentor guidance also helped us here. And of course, while reversing the audio, one more challenging came is like adjusting the PTS, DTS. Of course, for reverse video and audio, you need to see when you are reversing your first frame PTS should be the first frame, and you need to take care of all those things. When it comes to audio, So you need to reverse the samples inside the audio also. So what happened here is, I thought, okay, video is straightforward. I took the last frame and I just fixed the PTS and DTS of it, and then same works for audio. But remember that audio is all of samples. It is not about frames. It is just we are just packetizing it. So we're just putting some X number of samples as one frame. But if you want to tweak anything, you want to go to the low level and then tweak all the things. So here especially we want to reverse the samples also. So we need to go inside the frame and iterate through each, copy the source and the data from the reverse to reverse the samples. So that's the journey behind the reverse feature. So next it will be one more interesting feature. It's called compress. Yeah, lot of the times you see we want to compress a video because if you want to store it in a drive, or if you want to store in USB shared space, yeah, you definitely want to compress video. But there are a lot of compressing online. You need to upload it and then you need to download it. I feel okay, let's better to work on this particular compression feature. So first thing we thought is, okay, well, how do you achieve compression? So what are the key factors? At the same time, we need to ensure the quality is not compromised in the compression. Of course, a bare minimum of quality is compromised, but because the feature itself is compression, but it doesn't mean that it's not like it's not fully deviated from the original video. It's like there will be some kind of compression. So here is the original video and the compressed video. Of course, because of the small GIF, you can't really tell which is good. But yeah, from the human eye point of view, when I played both videos, yes, compressed video quality is little bit compromised, but yeah, it's still the good to human eye actually. So what are the factors which determines this thing? So one is CRF value, which is a one particular parameter which is both exists true for both video and audio. So it will compress the video frames, it will compress some audio samples, all those things, and then it will give us a compressed file. Let's say if you have 20 MB of data, you will easily get to up to 13, 14, 10 MB even, which depend upon the CRF value. So what is the right CRF value? The value 28 is good, 23, 24. So you need to figure out the CRF value. And max B frames, most of the things is good. We are very lucky we have identified this parameter because we have done in the video series enough on this max B frames, how this max B frames parameter plays a key role in if you're encoding. So let's say there are I frame, P frame and B frames. So which frames are used, what is the, it's all comes under low level details of the encoding algorithm. So last thing is audio bitrate. Yes, if you decrease audio bitrate, the size will compress, but given the audio bit rates, you don't see much difference, but we want to put that parameter. So next is like we also want to improve our compression algorithm based on one more additional parameter called video bitrate. Okay, so maybe tweaking this video bitrate will definitely help us to achieve more compression, but at the same time quality might be a bit low. So the challenge here is to understand the CRF value, which is the right appropriate value, whether it is low, it should be high. And if you are along with CRF value, if you are also using other parameters, interesting thing is same parameter doesn't work. So let's say if I put CRF 23 and I'm just compressing, it is compressing good. But if I put CRF 23 and if I enable max B frames as 1, then the compression is not that good. Means its size is bit more than when it comes to previous experiment. So we need to ensure if you're using CRF value in combination with the other parameters, ensure a balance is maintained such that the quality is not compromised and you want at least a minimum visibility should be there. And of course, as in this process, you need to fix different trade-offs. Like, okay, I only want CRF. I don't want to compromise on the quality. So like this, different trade-offs you need to do between size and quality. So this is one very good feature we worked on. So this is also very interesting thing called merge video. Yeah, please don't mind here. Just for simplicity point of view, I just kept two videos which are similar in similar original 1, original video 2, but here I am merging. You can see yeah, here the first video got end here. I mean the same video got end here and it will begin again. Yeah, you see here. So this original video, so this second video is coming now. So the first video end, I took a snapshot, and then yeah, the second, so now it's coming. The first video is almost to end here in this GIF, and then yeah, and then the second video started. Since we are merging based on concatenation way, I mean if there is a file 1 and file 2, both have same specs, like same video spec, same audio spec is same, then you can simply just, you don't need to encode, you just need to read the frame, write the frame, read the frame, write the frame. That's how you achieve the merge. But if down the line you also want to support this merge concept for if you have two different videos, have in the sense videos which has different specs, okay, audio codec ID is different for first video and second video, two different, let's say for example first video has X264, second video has X265. So now how do you merge them? So in this case you can't directly copy paste, read and write the frames, there will be a lot of ambiguities coming. So you need to encode the data of the each video. So you need to select, okay, which one I want. Do I need X264 or X265? You can stick to one and then you need to encode accordingly. Same works for audio also. And the challenging part is here is again the PTS and ETS. This is not leaving us. See, after the first video, the second video should start, right? So the second video PTS initially it is 0. Let's say explicitly take second video, that frame will be 0 PTS value. So if you start using those original PTS of the second video, overlap will happen between the first video and second video. So you need to define one offset such that the original PTS of the second video should shift to a value offset. Okay, so that offset need to determine properly. So we did some lot of hit and trials and understand how this particular PTS DTS for a packet happens, all those things, and finally we could be able to come up with that. So here we did some hit and trial. So you can see for different feature we faced different problem and we have overcome through that to the different approach. Not in every feature it's guaranteed that this approach will work. You just need to start with something, and if it works, okay, if it not works, cut down second approach. So for this merge we did one, we solved the challenge in one way, for compression in one way, and for reversing one way, and for playback in another way. But few commonalities will be there, but the key thing is just to ensure what makes best to solve that problem. Don't try to solve all at once, do step by step and then keep evolving, take your time. Okay, so that's one thing I noticed. Okay, so apart from these features, what is happening from the infrastructure point of view? So from infrastructure point of view, we started new POCs. This is a very good stepping stone in our MultiMagix, because web application is ready now. Ready means the POC is ready. So here we are, this is our local host, and then this is our backend server. So here we are uploading the file, so the file get transfers to the server, and in the server our application is running, and here we are printing the metadata. Good. So here we'll be keep on improving this web application, and the server will be the Raspberry Pi server here in this case. Okay, so the next thing is we also introduce the GTS GMOC. As you know, as a typical life cycle, software development life cycle, we already discussed how crucial it is, essential to run GTS or any unit test for that matter. So what's the significance of it, how it ensures a bug-free code much earlier, even before running in the customer side. So a lot of advantages we gain using unit tests. So we added couple of unit tests, we enabled it so that POC is working. So but the interesting thing is the coming 2 to 3 months we want to work on really on these areas where we can expand new features for all platforms, and we can expand system tests by using Python for all platforms. We can expand GMOC GTS for all the platforms, and we also want to maintain a DevOps CI/CD pipelines for each platform. And also we need to do some, as you know, if you are watching our channel, we are also working on the front full stack building blocks like login, authenticator, Firebase, like all those things are based upon the need and requirement. We will integrate those building blocks into our actual product. So a lot of things were planned actually. And last but not the least, you also need to start working on the updating the UI to support the new features for all the platforms. So there is a full stack, there is UI, there is DevOps, there is CI/CD, there is unit test, system test, product development, multiple platforms, whatnot. Everything is there. So a lot of intense work is required, and we are happy that we are progressing. At initial phases we are nothing. Now we got 10 features and we are up and running on a couple of platforms, and then we need to port that to different platforms, maintain all the basic standards. Organization is meaningful product development lifecycle, face the challenges, solve the challenges. Yes. So on that note, I'll conclude this video for today, and then yeah, let's meet you in the next video with a different concept in the MultiMagix. Until then, bye bye, take care.